Hi, I'm Juvel Calwalatian and this is my video presentation about the digital modulation. So this is my course project in Principle of Communication System. So let's proceed. So digital data transmission. So communication application nowadays send digital data over communication channels. So digital codes. The signal used to represent computerized data are digital rather than analog. Even before the advent of computers, digital codes were used to represent data. So digital codes, signals to represent computerized data are digital. Morse code, this is the first digital code. So consists of dots and dashes used in hand-operated telegraph system. Godot code used in early teletype machine. Used 5 bits to represent letters, numbers, and symbols. American Standard Code for Information Interchange. So 7-bit binary represent 128 numbers, letters, punctuation marks, and other symbols represent both uppercase and lowercase letter of the alphabet. Have 2 and 3 letters designation to initiate operation or provide responses for inquiries. So, early digital codes. This is the first digital code created by Samuel Morse, the inventor of the telegraph. Originally designed for wired telegraph communication, but was later adapted for radio communication. So this is the Morse codes. So modern binary codes. So modern data communication information is transmitted by using a system in which the numbers and letters to be represented are coded. So this is the American Standard Code for Information Interchange. This is. So the first ASC2 codes have 2 and 3 letters designations. These codes initiate operation or provide responses for inquiries. So hexadecimal values. The ASC2 code for the number 4 is 0110100. So add the leading of 0 to make 8 bits and then divided into 4-bit group. 00110100 equals 00110100 equals hex 34. So extended binary coded decimal interchange code. So what is EBCDIC? That is extended binary coded decimal interchange code. So it's developed by IBM. Is an 8-bit code similar to ASC2, allowing a maximum of 256 characters to be represented. So ways to transmit data. Parallel transmission. This is not practical for long distance communication. And the serial transmission is a data transfer in long distance communication system. Each bit of word is transmitted of one after another, and each bit transmitted for a fixed interval of time t. So speed of data transfer, number of bits per second, that is a BPS. And then the speed of serial transmission, bit time of a serial data. So speed in bits per second is a reciprocal of the bit time. So principle of digital transmission. This is the serial transmission. And this is the parallel interface example. Transmitter TX and receiver RX. And then this one is the serial interface example. This is the transmitter TX and this is the receiver RX. This is the MSB and LSB. This is the LSB and this MSB. So you can see that this is that is the difference between the parallel interface and the interface example and the serial interface example. So, an example is a system that represent 2 bits of data as different voltage level. So, with 2 bits, there are 22 equals 4 possible levels. And a discrete voltage is assigned to each. So, 0 voltage, and 1 is a 1 voltage, 10 is a 2 voltage, 11, 3 voltage. So, this is the asynchronous transmission. Have a sender and receiver. This is stop bit and start bits, start bit, stop bit, start bit, and this is the data bits. So this is the asynchronous transmission. Then this is the synchronous transmission. So you can see the difference between asynchronous transmission. This is the sender and data, sync, data. And this is the receiver. From 1 to 0, this is the continuous stream of data bits. That is the difference between the asynchronous transmission to synchronous transmission. So, encoding methods. Encoding method, this is usually encoded in some way to make it compatible with the medium or to facilitate some of desired operation connected with the transmission. So, non-return to zero, return to zero, Manchester. So, transmission efficiency. The accuracy of a speed with which information, whether voice or video, analog or digital, is sent and recovered over communication media. So, this is the Hartley law. Mathematically, Hartley law is stated as C equals to B. So, where is the C channel capacity expressed in bits per second? And B is the channel bandwidth. So, it is also assumed that there is a total absence of noise in the channel. When noise becomes an issue, Hartley law is expressed as C equals log 2 1 plus Sn and N. So, where S and N is the signal to noise ratio in power. So, this is the transmission media and bandwidth. This is 1 circle, 2T. And this is the digital modulation techniques. By using broadband communication techniques involving modulation implemented by the modem, a device containing both of modulator and modulator and demodulator. So this is the spectral efficiency and noise. Spectral efficiency is a measure of how fast data can be transmitted in a given bandwidth. So this is the modulation, FSK, GMSK, BPSK, QPSK, APSK, 16QAM. And this is the spectral efficiency, BPS, and Hertz or Hertz. So, that one. And this is the wide band modulation. The goal is to minimize the use of spectrum space and to transmit the highest speed possible in the given bandwidth. So, spread spectrum, SS. So, SS is a modulation and multiplexing technique that distributes a signal and its sidebands over a very wide bandwidth. So frequency hopping spread spectrum. So binary data to modulator or FSK or PSK to STDT and also the FH. This is the FH spreader, and this and going to band pass filter about some of frequency to spread spectrum signal. That is the spread spectrum signal. So this one is the FHSS transmitter. This one have a Pseudonos bit source to channel table to frequency synthesizer to CT, like that. So direct sequence spread spectrum. So this is the data in going there, the PRS and the wideband modulator carrier, the generator, and this is the DSSS transmitter part, and this is the DSSS receiving part. So you can see this is the data in and this is the data out. It's the same, but it's data in and data out. That's the difference between the two, the transmitter part and the receiver part. So orthogonal frequency division multiplexing or OFDM. So OFDM is known as a multi-carrier modulator and modulation, MCM. So first proposed in 1950s but was not seriously considered until 1980s, and the early 1990s today fast DSP chip make OFDM practical. So broadband modem techniques. A modem or modulator demodulator is a circuitry used to translate a baseband signal, usually digital, to a higher transmission frequency that is a better suited to the transmission medium. So cable modems. The digital data is used to modulate a high frequency carrier that the frequency multiplex into the cable that also carries the TV signals. This is the cable modems. So this is the transport ring, headed distribution, that one distribution. This is the optical node. That's why we have a cable modems. That is the line of amplifiers going to our cable modems. So that's all, and thank you.